Hi, everybody, and welcome to Do iOS 2022. As Jeroen so nicely introduced me, my name is Ben Proothi. I live in New York. I'm 16 years old. I'm a high school student, and I am also an iOS developer. Today, I'm going to be taking you guys through time traveling with Swift. We're going to look at where we started, where we are, and where we're going. My thought with this presentation was to create a history for dummies type book for Swift. So really, I go through in the simplest possible terms, how did we start out and why will that origin story influence where we're going with the Swift language? So just to start off, we need to go over what is Swift. Now, most of you guys know, or else you wouldn't be here. And if you don't know what Swift is, this might be a long 2 days. But for the rest of you, I'm just going to give you guys a little bit of context. Just go over almost what is Swift, not from the textbook definition, but what are all of the little quirks that influence what makes Swift different from all other programming languages. So here, as you can see, is our textbook definition. This is direct from Apple. We got Swift is a powerful, intuitive programming language for blah, 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 blah. All right, the rest of that you can read on your own if you want. It's kind of boring. Next slide. My definition of Swift goes through really what are the attributes that make Swift Swift. So Swift is object-oriented. That means we have classes. We have almost these blueprints for classes that you can see up on the right. We have Swift is type-safe. Type-safe mostly meaning that inputs, outputs are defined, variables are defined as a specific type, and it really just keeps Swift almost obvious to the reader so that you know when you look at code, as long as it is functional, it will, if it runs, it's going to be more likely to work than when you have Python and it's running, you get halfway through your program and you're like, oh, so that's supposed to be a number, not a word. Yeah. In Swift, luckily we don't have that happen. Functional, again, functions. That's pretty obvious. It's pretty clear. We have this syntactic sugar. You can see up in our function definitions, we have those arrows to indicate outputs. It just makes things easier to read, easier to understand. Everything in Swift is kind of built with that reader in mind so that you can hopefully understand what the code's doing without running it, but just by reading it, where you have a lot of languages and it just doesn't make sense like that. What does high level mean is another thing. I have high level up here. High level is kind of a weird word because, to quote Steve Jobs, high level just means it just works. Now, Steve Jobs got a lot more applause when he said that. I'm just saying, like, you guys gave me nothing here, and all right. But I'm done being disappointed about that. Moving on. Just looking into the past of Swift. Now, I'm not really the AV guy here. Marco's got that. But for you guys on your own, you guys can make like time travel sounds if you want to in your head. I kind of am going to go with like the DeLorean here. If you guys want to do your own time travel sounds, fine. I'll leave that up to you. But yeah, I'm going to be making DeLorean on my own. So do what you want. Just looking at the Swift family tree here. So I like to think of Fortran up there as kind of the godfather. For those of you who are into mafia movies. Then you have Objective-C, who's kind of like the father of Swift. You got the older brother, who's TypeScript. You got this like weird cousin, Kotlin. He's not even on here because we don't really want to talk about him, but you can kind of just ignore that. We left him off the family tree. But yeah. The next thing to look at is where did Swift come from and where was it born? You can read through here. At the time that Swift was developed, it was officially just codenamed Shiny, as in it's some sort of shiny new thing. This was from the creator of Swift himself, Chris Latner. And with the intention behind Swift was to create something new that would revolutionize iOS development. Again, you got to use that word revolutionize. It's in every single Apple presentation. Just go with it. But for now, the purpose was to revolutionize iOS development by getting rid of all of what could be considered dead weight and the things that were really only in there because it's always been done like that. And as we kind of learned with Swift, it's always been done that way is generally not the best reason to keep something around. Now, going back to that high-level programming language that I mentioned before, High-level programming is really what starts the birth of Swift. It's kind of this spark that would grow into creating an entirely new language just because of one cause. And high-level programming is a little bit weird because when you think of high-level programming, it seems like it should be advanced, high-level, except it's really the opposite. High-level programming is the easy-to-use stuff. It's the idea that what you're coding is obvious to the user. Everything's very intuitive as opposed to having to deal with all of the nitty-gritty of your code on your own. Now, with Swift, we first started off our kind of separation from Objective-C with this ARC, automatic reference counting. With automatic reference counting, the idea is that imagine you are taking a leash and attaching it to every object that you create. And as soon as you run out of leashes, your dog of sorts kind of just runs away. So in the code over here, you can kind of see you have this parent and child class, where the child class is going to hold just a reference to its name. The parent class, on the other hand, holds a reference to the child. When I create this parent with a child named Dana, and then I change that child to be Zool, you find that you can't find Dana anymore. There is no Dana. There is only Zool. And for those of you who somehow have not seen Ghostbusters, the general idea is just, again, once there's no longer a reference to an object, it's deleted from memory and it can't be recovered. But sometimes that's okay. That can be kind of the purpose of our code. So with Swift, we often encounter these reference loops, and we had to find these ways to navigate around that. Whenever you have a parent and a child class that are going to be referencing each other and holding on to each other, it's like having the dog have a leash to the owner and the owner's a leash to the dog. And if you cut either leash, it doesn't really matter because you're still tied to the other one. Regardless, not a great situation. And when this happens in our code, you get these memory buildups that become huge. Your code crashes, your entire app crashes, you get rejected from the Apple review process. You got to go back to the drawing board. It's not a fun process for anyone who's been through it. But that aside, Swift gives us some ways to fix this, to get around it. So those of you who have used that like weak var all the time, you may find it literally all over your code whenever you're dealing with storyboards and the UI kit. That's where you have kind of optionals for everything to prevent the reference loops that you can kind of see on the right here, where your parent class and your child class are just going to hold each other stuck in memory forever. And that just becomes wasted space on your phone and a mess to deal with. Swift, hopefully, finds us a way out of that with the weak types, but you also have another option, and this option is deeply, deeply terrible. So this option is to just get rid of reference types entirely. Now, why you would ever do this, I'm not really sure. It's not the best approach. It's certainly an approach, and you can also just like try it out for fun. I don't see why you would. But this is a direction that Apple has even looked at in the past, and we'll get a little bit more into that later with its shift towards structs over classes. The next thing to look at is what happened when we introduced this automatic reference counting to Objective-C. Now, the whole point here of looking at that ARC is to see how did Swift split off from Objective-C, and it really just comes from this fundamental incompatibility between automatic reference counting and Objective-C. So automatic reference counting does get added to Objective-C in 2011. However, you find that a lot of existing Objective-C code just isn't compatible with automatic reference counting. So as you can see kind of off on the right, I'll blow that up a little bit. All of these errors come up whenever you try to use existing Objective-C code with the automatic reference counting, because all of the attempts to use low-level commands on Objective-C that have to do with memory allocation specifically start to break down, because automatic reference counting is like, I'll take this out of your hands, I can handle it on my own. Whereas then the Objective-C language itself, you're really focused on, well, I'll handle the memory by my, like as the programmer, I can do this. Automatic reference counting wants to do it itself, and now you have this collision between two different ideologies of, is it more efficient to do it on your own or to just let the actual device and all of the software in there just handle it by itself and make it not your problem? Personally, I'm always for the it's not my problem approach. But for those of you who already have code that exists with the it is my problem, that's where we kind of have this clash, and Objective-C just doesn't work well with that automatic reference counting. And because of that, they start to break off, and you end up with Objective-C wants to handle everything on its own. Swift and this automatic reference counting idea wants to take this cheap way out, but the cheap way out might not be such a bad thing. And that's where you get Objective-C without the C. So this quote by Craig Federighi himself, the only 53-year-old who has better hair than me, he goes through Objective-C without the C when he's creating the, or really announcing the Swift language. The idea here is, how do we take Objective-C and make it compatible with high-level memory management, allowing for the use of that automatic reference counting in a setting where C languages generally want to handle memory management on their own. And what he does here is he essentially takes Objective-C, which wants to handle that memory management on its own, and he just rips out all of the C code that is kind of what's holding it back from enabling that high-level memory management. And with this, you start to get what I describe as the speciation of Swift. So speciation is really a biology term, but I think it's particularly fitting here. Darwin used it to describe the separation of species in like finches and tortoises and all sorts of stuff that I don't really know about, but we don't need to talk about that here because we're software developers. We don't go outside and look at animals. This is where we start to get a split between Swift and Objective-C, at which point they both become their own languages that can operate more independently of each other. And with this, we are able to build our own language with Swift. Swift, there was the ability to add in clarity. We got rid of the pointers that kind of just get in your way. You can fully implement automatic reference counting without dealing with those millions of errors showing up whenever you're using legacy code. Value types start to be introduced with full support for reference types still around. So in this situation, we start to introduce structs in a way that with Objective-C, they are, now you can kind of use them. They're not necessarily encouraged, but Swift really becomes more dependent on structs and value types, which especially with Swift UI has become increasingly important over the last couple of years. So that still leaves us with one small problem, which is that Swift is dependent on Objective-C. And our only real issue with that is that we still are stuck with UIKit up until now. And UIKit is entirely based off of classes, which are those reference types. And that leaves you with that whole ARC debate over, should I be using high-level memory management, low-level memory management? Objective-C is kind of pushing for that low level. Swift is pushing for that high level. And at the same time, they're still so tied together because whenever you're using Swift, you are still fully dependent on the existing libraries that are made with Objective-C. And that's where we have Cocoa Touch. So I'm just looking at this. Cocoa Touch we need for UIKit and Foundation and everything that makes the apps work. So if we were to get rid of that, it's okay. We would just lose out on UIKit and Foundation and so we can't really get rid of that, which kind of leaves us with a small problem. How do we make Swift work without the existing frameworks? Don't worry about it yet. We'll get to that later. For now, we're in this Gilded Age of Swift. And the reason I call it a Gilded Age is because just like in history, a Gilded Age is when things look great on the outside and inside they are not so great. But for Swift, things are great for sure. Before Swift 2.2, it was closed source. We kind of have this huge growth of Swift. New features are constantly being added, and with this, things seem to be going well, except we have a couple things. Like we got all this stability, except how do we feel during that time? Yeah, not so great. During the Gilded Age of Swift, as I call it, Swift stability is a huge issue, and we're going to get more into that in a bit. But for right now, stability remains one of the huge things holding back Swift from being kind of the ab initio, as you could say, language of choice for developing apps. You don't really want to build a project entirely with Swift because you're always concerned about, well, what happens in the next release and my entire thing breaks? Or what happens in this release when my entire thing breaks just because the code wanted to? The next issue we have is backward compatibility. And this one's fine, right? Because Swift is closed source. As long as Apple's controlling everything, they make sure that the last version work with this version and the next version and the next version and the next version, except for the one small problem of, oh, wait, it's not closed source anymore. So the open sourcing of Swift becomes this huge debate over, yes, it's great because it enables creators all over to have their own input into the Swift language, and all sorts of new features are going to stem from this open sourcing of Swift. However, backward compatibility wise, you do run into the issue of, now that there are multiple contributors and all sorts of different versions of Swift that are floating around, how do you make sure that everything works with existing versions? And so with that open sourcing of Swift, you have swift.org created, you have the Swift package manager, you have this Apache 2.0 license kind of controlling Swift, and that Apache 2.0 license is this like weird legal stuff that essentially just means do what you want with the language. It's not our problem anymore. Although it still kind of is your problem, Apple, because at this point we have the problem of backward compatibility becoming completely uncontrollable. And we need to kind of solve this problem and find a solution that works for all sorts of new versions that are coming about with the open sourcing without sacrificing the creative leeway that comes with open sourcing Swift. And this is where we get to the present. So again, you guys can do time travel sounds if you want to, but moving on. We're going to start out with what I would describe as the state of the language. The state of the language is essentially saying, well, what is up with the Swift language in the last couple of years? For those of you who've seen Talladega Nights, Ricky Bobby, he just wants to go fast, and that's really what's happening with Swift here. For those of you who haven't seen Talladega Nights, I'm kind of disappointed, and you guys should change that, but that's a problem for later. For now, you guys can just focus on Swift. It is fast now, I think. How do we really know that? Well, we can compare it to other languages. See, these numbers sound really complicated, and at least complicated enough to seem real, like there's some sort of math behind them. And they seem to look good. It says that Swift is, 8.4 times faster than Python 2.7. That seems to be a good thing. But again, Python is interpreted, not compiled, so you do have that issue always kind of holding you back for Python. And the source for this is Apple, but we're going to ignore that part because they definitely don't have any bias there, for sure. As opposed to Objective-C, again, Swift is 2.6 times faster. Objective-C does use some sort of runtime compilation, where Swift does not have this just-in-time compiler really holding it back at all, making Swift appear a lot faster, even if it's really kind of handling less of the work each time it compiles. But again, that's just smart engineering. You could really say here that Swift is engineered with compilation speed kind of in mind to begin with, because when Swift was designed, you have the idea of, let's try to compile as much as possible before you even launch that app so that the just-in-time compilation doesn't need to hold back the speed of the language. And that kind of makes Swift this kind of symbol for speed in programming. And that's why it has a bird on fire, because fire for some reason means speed. I don't really know why, but whenever we associate things, fire somehow equals speed. We got Firefox with the speed. This Swift kind of looks like a phoenix. I don't really know. But Swift, for some reason, they decided was going to be fast. That's also why it's called Swift. Now, why they decided to make it a bird, we'll never know, but it doesn't really matter. Back to our other problems. Swift remained dependent on Objective-C. So how did we solve that? We start to push towards value types. Now, before we had Cocoa Touch, and that was the thing that was holding us back because we were stuck with Cocoa. And again, everything that makes apps work is classes. Classes being reference types, we run into the small issue of how do we kind of speed up Swift and allow it to be that independent force from Objective-C without compromising on the things that make apps work, Cocoa Touch. Now, we're missing this piece in the middle, and there's just something missing. And as we start to develop Swift into its own fully functioning language, it kind of gets that push that it needs. And that push comes in the form of Swift UI. Swift UI is that final brick in the wall between Swift and Objective-C. In other words, it's the last little wedge that kind of pulls them apart and makes Swift a functioning language on its own without the need for the low-level Objective-C code to hold it back. Now, part of what makes Swift UI this force for dividing Swift and Objective-C is the push towards structs. Now, structs are great. Structs are lovely. We love structs because they allow for code to memory rather, to exist as its own piece that is not, rather than tying 50 leashes to the dog, you just copy the dog. Now, at times that can seem counterintuitive, especially when you have, 50 of the same dogs running around, and that becomes kind of pointless. So there are certainly still times to look back towards reference types, but the advantage with structs is that their performance is significantly faster. Now, you can kind of see here that Swift and Swift UI are this like match made in heaven, partially because they're both designed with this like need for speed in mind. So while value types are stored in the stack, reference types are stored in the heap with addresses stored in the stack. So each time you add another reference, you're going to kind of add to that stack. And the reference counts have to be recorded on their own, which takes up additional computation time because every time I decide to add another leash to the dog, I have to write down somewhere that I added that leash so I don't lose track when I have 200 leashes attached to the same dog. And that becomes a really difficult dog to manage. And it just leads to this bloating in your code. Now, looking in there, the next little issue we run into are actors. Now, actors are great in some ways because they enable concurrency. And at the last conference I was at, 360 iDev, we did look at the actors super in depth. And basically everything that I had heard about them was positive. Now, at this conference, I don't know how that's going to go, but I can assume that the same thing will follow, that we're going to look at actors through this extremely positive light, because on a basic level, it is simple concurrency. However, there's a little bit more to it than just concurrency, because I would say actor is a good name, partially because it does kind of leave this connotation that something is in disguise. Now, what's in disguise here are reference types. So once again, no real need to go back through that again, but reference types are going to hold us back a little bit in terms of speed, and that's part of why Swift is going to make that shift towards value types, especially with the introduction of Swift UI. Backward compatibility was our other issue that we ran into before with separating Swift and Objective-C. Now that we solved the first problem, we can kind of look deeper into this. When Swift open sourced, we had a whole new array of issues open up. Okay, I'm really sorry for that pun. A whole new set of issues. Okay, moving on. A new grouping of issues that is neither an array nor set or collection, because those are bad puns. Moving on, we have backward compatibility issues across the board that are at least partially solved by the Swift ABI Stability improvement. Now with this, Swift runtime became included in the Apple OSs on their own. So as you can kind of see here, we have our app bundle that kind of is requesting that golden SDK at the top. Now when a new version that we can represent here with the red one, when that new version comes out and the app is looking for the older version, the app knows to look for that. The app knows that the newer version will work, and any newer runtimes can handle older apps. And this means that no matter which version of Swift your app was compiled with, all future versions can hopefully support that app. This is more similar to the Objective-C runtime, where you no longer have the runtime kind of built into the app, where you have essentially two pieces that both need to be on equal footing. Now, as long as you are running the same version or a newer version on your device, it will work with the existing versions of the app. And as you can kind of see here, this makes Swift a little bit more, as I would say, future-proof. Now that Swift is open source, version control becomes a huge issue to look at. Now, this means that an app compiled with, let's say, Swift 5.0 is going to work on a device that has Swift 5 and Swift 5.1, and in the future, possibly some sort of Swift 6 that finally comes to be. They really kind of pulled an OS X here, where you have Swift 1, 2, 3, 4, 5, and then 5.1, 5.2, 5.3. Maybe one day we hit Swift 6, and I'm confident, now that we have the ABI stability, that even Swift 6 will support the apps that are created using Swift 5.0. The next thing that really comes as an improvement here is app size. So as kind of a byproduct of including the runtime on the device rather than caked into the app, you have app sizes decreasing. So where before we kind of had these three duplicates when we would launch three apps, because different pieces of the runtime are built into each app and they become redundancies. Whereas now we have 3 independent apps that have everything they need to run on their own and only one version of the actual Swift runtime on the device itself rather than built in with each app. And this means the duplicate files on each device are minimized, apps are smaller, and that just really helps everyone. In addition, not only does it decrease storage, but it's going to improve our efficiency with respect to time. So our system library is now ready before app launch because rather than needing to compile that like with Objective-C where we had that just-in-time compiler that really slowed things down, we now are able to compile this well before the app even launches. So instead of having to deal with launching 2 different pieces of technology, we just launch the app itself each time you tap on that button on your home screen. That's all that's running. The actual information needed to read your app is already up and running in the background on your phone, and that's going to make launch time smaller. We already have file sizes smaller for your apps, and it just essentially takes Swift and improves the efficiency while also increasing compatibility. And so this becomes this turning point in Swift where it finally becomes something that is more standalone because it has the features of existing languages to handle its own legacy code. So this is also this ideological shift for Swift because before you have Swift as this new technology that doesn't need to work with old stuff because we say that it's just new and shiny and it's almost a gimmick. And now it becomes this full self-sustaining language where it is able to work with its own existing versions. It can work with existing versions of Objective-C, and compatibility just becomes a primary target for this language. In addition to the app launch time, where I talked about how the standard libraries are going to be preloaded, if you will, dynamic libraries are introduced, and this allows for third-party libraries to act more like this updated standard library, where they're no longer just part of the app binary, but they exist on their own on the device. And this is great because what it does is allow for individual apps that, say, use the same SDKs. So let's say I had 5 apps that all use Stream here. Rather than having to create all of these duplicates that exist within each app, your device is going to host one version of it that different apps can interact with. And this is kind of done with that static linker that you can see in red over there. The static linker is essentially taking the libraries on your phone along with the source files that belong to your app and combining them and allowing your app to utilize the existing libraries. And rather than having to again, load those up at runtime all together, you just have the references to the external libraries that are loaded independently at their own runtime. Now, just to move on from the state of the language to what I would call the quirks of Swift. So before I get started with this, I'm going to keep this section somewhat short because, again, this isn't really time travel here as much as space travel. So we're still going to be looking at the present here, but I want to kind of take us to a different region of what is up with the Swift language today. Starting off, we have this weird mess. There's null and nil again, and there's NS null, and they're all very different things that all look exactly the same, at least to me. So if you want to read through these definitions, you can, but just the brief rundown is capital N null is just a result of C pointers. It's kind of this issue with C being the grandpa of Swift, if you will. They're all kind of different flavors here that all just mean nothing. So this is like chocolate nothing. This is vanilla nothing. We got strawberry nothing. Whatever your preference for nothing is, they're all very, very different, and you would need to know exactly what each one does because they're all separate except they look the same. So that's not an issue at all. Don't worry. Aside from that, we have lowercase nil. This is the one that you're, I'm sure, most familiar with. This is just for Objective-C objects and in turn Swift objects. This is our like literal null value. For capital nil, this is for Objective-C classes. So whenever you're dealing with like JSON decoding and you have to put in like, I don't know, string.self, what if you wanted to do nothing.self? Now, I don't know why you'd want to do that, but Swift leaves us with that option just because. At the same time, we have NS null. This is going to represent null when null is not allowed. So Swift did all this great work with introducing optionals that made our lives easier in terms of here's when something can be nothing and here's when it can't be nothing. So sometimes when it can't be nothing, we still want it to be nothing. Again, I don't know why you would want to do this, and go around all of the great stuff that Swift has in terms of optionals. But sometimes when Swift says no to optionals and you just want to break the rules and do it anyway because you're a rebel like that, NS null is here for you. Speaking of that NS null, why is everything NS? So this dates back to 1985 when Steve Jobs leaves Apple, founds Next, and Next is who licenses Objective-C in the first place. And what that means is that AppKit and Foundation, which were kind of those starter libraries for Objective-C, were developed not by Apple engineers, but by Next Step engineers, and NS gets adopted as a prefix for that. So that's why all of the Foundation classes that were originally created with Next Step in mind and are later transferred over to Apple say NS, because nobody really then wants to change the names once they become an Apple thing because of, they're lazy. But at the same time, backwards compatibility, so that existing code that labels things as NS data, NS string still works on the newer code. And Swift has slowly been trying to step away from this. That's why you'll see, Swift UI now has more things that get rid of that NS, since it's no longer reliant on Foundation as much as its own new models. And that's why you see with Swift, you now have string, data, all of these types that still work really well with the original NS data structure, but they're slowly trying to step away from that so that instead of having to use, NS string, UI image, you can just use image string with Swift UI. And that makes our lives as programmers easier because we have to type 2 letters less. And as programmers, we're lazy, so that's fine. Next thing to look at is protocols versus interfaces. So as you may have kind of observed if you ever worked with Java or a bunch of really other languages that use what they call interfaces, we have protocols that are very, very similar but use a different name for the sake of I don't really know why. One possible reason is just for clarity because of the .h header files that are full of @interface at the top to, start defining your classes. Partially just because of that, so that we don't have a bunch of things all called interfaces, but also just because protocols enable us to use one of the big Swift features that kind of makes it distinct from other languages, which are extensions. And by enabling extensions, we say that protocols are this whole new thing because you can create a protocol, you can extend that protocol, and you can add all this extra functionality that an interface in Java wouldn't necessarily have. And because Swift developers are on our high pedestal, we say that, well, our protocols are extendable and interfaces aren't. So we need our own name for that so that people don't confuse the two, because we don't want to be associated with the lowly interfaces. But aside from that, it just sounds better to say that you're doing protocol-oriented programming because it makes you sound like a cool tech wizard. Now, again, space travel, not time travel here. You can start to throw in your gunfire and battle noises if you want, because we're going to be looking at the cross-platform war. So even within this room full of all Swift developers, I think there is a chance that this starts to get a little bit divisive. Now, cross-platforming Swift has become a huge issue in recent years because there are really advantages and disadvantages to both sides, whether you want to look at doing your UI so that it works with iOS devices, Android devices, Mac devices, Windows devices, all sorts of different things all at once, or whether you want to take the time to kind of build specific apps for each one. And there are advantages for both sides. Now, just looking at some of the key players in this war of sorts, we're just going to start off looking at UI. And so with UI, you have the competitors to Swift UI, which is kind of Apple's alternative to UI, especially in recent years with the push away from UIKit. So this is kind of born from Zuckerberg's metaverse. You have React Native. You can read out, if you want to, what all the different devices it supports. Long story short, it supports a lot of devices and a lot of different operating systems. So this is going to include the Quest VR platform, whereas Swift UI does not support a UI platform, a VR platform that I know of yet, which we'll see if that happens in the future. That'd be pretty interesting. But for now, if you're looking at VR, you may be pushed towards this kind of metaverse idea that Mark Zuckerberg has decided to throw his weight behind. This has a declarative UI, much like Swift UI. The language of choice here is JavaScript, and the nice thing about that is that JavaScript is somewhat universal in how it's not really something that's only going to work for React Native. If you've learned JavaScript for other endeavors, React Native is not so much of a new system, so there is that advantage to it, whereas Swift, if you're not doing iOS development, the odds that you've learned Swift for something else are somewhat slim. I'm not personally a fan of JavaScript, again, just because that, weak typing, whereas here, there is at least the option to use TypeScript if you are interested in static and strong typing, especially if you're coming from an iOS development background where you do have the strong typing of C, Objective-C, and Swift. Another option you have is Flutter. This is Google's entry into that space. Again, it supports lots of platforms. It has widgets, but not really like the cool iOS widgets. It's just these loser Google widgets. Okay, not to throw shade at Google, but Google did create Dart, which is this Swift's first cousin once removed at this point. I don't know. The family tree is starting to get a little bit shaky. It looks all weird. But this has, again, the declarative UI framework, much like Swift UI, but it's based off of Google's technology and works, again, with far too many things for me to list because I don't want to read that. Microsoft has done the same because, again, that's kind of what we've fallen into in tech is everybody does the same thing and sticks a different label on it. But Microsoft version is what they call Xamarin, and this is going to use the .NET framework to build cross-platform UIs. Again, supports a lot of things, uses C#. C# is really interesting to me, especially because it looks a lot like Swift, but they're definitely not related. This is like some sort of distant cousin who for some reason has a lot of the same look as Swift, but it's not Swift. Now, who really wins this war? Now, looking at UI specifically, Swift UI has a lot to offer, and what we have here are performance, we have native feature support, scalability, and the languages that are kind of brought with Swift. The language features that come with Swift are enabled on Swift UI right away. Whereas when you're looking at the other cross-platform options, you run into longer development times if you're looking at Swift UI, whereas the other development platforms allow you to kind of push to all sorts of different operating systems and devices with one click, and that really helps. It is harder to maintain when you're dealing with each different device and operating system on its own. Cross-platform apps that now can be built with native UI elements on the cross-platform options. I wouldn't say that this is necessarily a con for Swift UI as much as something that was a con for the native the cross-platform options and now no longer is, so it's really a pro for them. What you get here is you can now use native UI elements on the cross-platform different software technologies, and what that allows for is an app that looks and feels just like a Swift UI app, even though it's built using something like Xamarin or Flutter. Now, this has led to a couple other issues, including developer shortages. So developer shortages becomes this issue here where if you don't have someone on your team who exclusively deals with iOS, then your app is most likely just going to be built using a cross-platform technology simply out of necessity. And that is something that does kind of push us towards the cross-platform things as opposed to somebody who's going to be building your UI with Swift UI, just because if I have somebody who already can build all of my mobile apps, be it iOS or Android, is it really worth hiring somebody to build just the iOS app and having another specialist focus just on the Android app? And again, that becomes a question of how big is your company, what resources do they have available, and so that is something that is specific to each circumstance, but does in some cases push people away from Swift and Swift UI. Now, we're running a little low on time here, but just to go through the future, you can go through more DeLorean sounds if you're interested. This is the last time, I promise. I'm not really a wizard here, so I can't predict the future with certainty, but I can say that these are some of the possible areas of expansions that I have seen. They're not necessarily facts. Now, winning the cross-platform war, again, becomes our next issue here. How do we do this? We do have this David versus Goliath situation of Swift being this newcomer to the field as opposed to the existing platforms that have been around for a lot longer. How do we manage to push Swift out as its own entity and say that there is a reason to use Swift and Swift UI instead of just building your UI with cross-platform technologies. And David gets ready with his stone to throw, except he kind of just puts it on the ground and decides not to because he realizes maybe it is in some cases better to kind of, rather than trying to fight off cross-platform technologies, you just kind of expand and support that idea of integration with other technologies. And what this takes form of is cross-platform Swift. So while the UI hasn't necessarily caught up with this, and Swift UI is not really being applied to Android and other platforms, what you do have is Swift itself being supported on other platforms now. And this is really a byproduct, again, of that open sourcing, which really was a turning point for the Swift language. You have integration with Linux and Windows. You have SCADE, which is a new technology that allows for Swift to be used for Android and iOS development on mobile platforms so that your apps look native, even though both of them are just built using Swift. This is a really new technology that has only entered its like final production stage, I would say, in the last 6 months. And all of these new opportunities come just from breaking things off with Objective-C. So while Objective-C had been holding things to the Swift needs to be for iOS only, macOS only, now because Swift is separated off into its own thing, it can be integrated with other technologies in a way that it wasn't able to before. And now looking back at Objective-C, let's see how that worked out. Like, what happened there? And it's not great. So what you can see over here is from the 2022 Stack Overflow Developer Survey, a whole lot more people now do extensive development in Swift than Objective-C. So you have 1.8 times as many people using Swift extensively, as they would say, than Objective-C. And what this means is that Objective-C is falling not necessarily into becoming like vintage technology, but it is becoming less and less used for new technologies that are being started from scratch. If you're building an app from nothing, the odds that you are building it with Objective-C now are so low. Generally, Objective-C is being maintained in existing code bases, not in new projects where they have the opportunity to start out with Swift. In addition to that, the Popularity of Programming Language Index now ranks them pretty evenly. Swift still wins out slightly. Now, what I will say here is Objective-C searches could be coming from a different place, at least from the developer's perspective, than Swift searches. And so what you see here is that Swift is only slightly beating out Objective-C in searches on Google. And the reason that I say that these numbers may be slightly skewed in Objective-C's favor is that these are people looking up Google tutorial searches for that particular language. And why are people looking up tutorials for Objective-C? In many cases, it's because you have a person working on a code base that has Objective-C legacy code, and they just don't know how to interact with the existing code because Objective-C has kind of fallen behind to a point where there are people who are coming into this industry with the intention of working primarily with Swift, not with Objective-C. And so the searches for Objective-C may not be coming from, Objective-C is the primary technology that we're using, but it is not the primary technology that we're using, and we need to almost learn how to deal with that older code base. Now, where is Swift going now that Objective-C is in the past? Machine learning. Now, you can't really blame Swift because every technology has kind of just been shifting towards machine learning at this point. Is it necessary? I would say sometimes yes, sometimes no. But is it a buzzword? Definitely yes. Now, how is this done? All sorts of new technologies for Swift have kind of opened up in recent years. TensorFlow has enabled differentiation with Swift. As a math nerd, I really love this. You have the opportunity to use Swift in all sorts of mathematical contexts, as you can see up on the right. This has enabled all sorts of new technologies, including Penguin and Swift RT, which allow Swift to be used at a crazy fast rate so that it can be used in science and all sorts of different scientific modeling technologies. At the same time, you have server-side Swift. There's a whole separate conference about this that I'm not going to look at because that's their problem. We're at this conference. One name really says it all, server-side Swift, Swift for servers. The only issue for this is that, again, we run into the low-level programming issue. Now, low-level programming is not really something that jives with Swift, as we talked about being the entire reason that the language came to exist in the first place. However, when you're dealing with server-side technologies, you really want something that is low-level. So how do we make those compatible? There are technologies such as Vapor. Vapor is kind of this newer technology that essentially allows for a high-level memory management language like Swift to interact with the low-level technologies that are wanted on a server. And this allows you as the programmer to work in a high-level language, and it essentially behind the scenes is going to convert whatever you're saying into the low-level commands that are needed when you're dealing with the server. And what this does is it allows you to use things like automatic reference counting on a low-level system like a server. And what this means is that the future of Swift, looking towards that transition back to low-level programming using a high-level language, kind of goes back to that very beginning when we looked at what broke us off in the first place. Well, Swift started because we needed to use high-level programming. And now it's pushing us back towards this low-level programming in a way that kind of allows the language to come full circle and become a standalone technology. Now, just before we head out here, I do want to give a special thanks to the Do iOS team, CocoaHeadsNL for putting this conference on, Swift.org, Apple developer for giving us some of those great definitions that we were able to skip through in the beginning, Techie Academy, NS Hipster, Stack Overflow, and the Popularity of Programming Index for giving me some great data on why Objective-C is falling behind. Now, just as we leave, I just want to leave you guys off with a question. Where to next? So I gave you guys some of a description here on the future of Swift, but it's really up to all of us as iOS developers to be able to answer this question in the future and see where is Swift going to go next. Thank you, guys.
Do you take questions, Ben?
Yes, absolutely.
Please raise your hand, and then I will throw this thing in your face. No, I'll be gentle. So, anybody have a question? Works every time. Nobody? Axel, maybe you? You you always have fun with this thing.
Hello?
Good catch.
Hello, is it on? I don't know. You mentioned server-side Swift on low-level hardware, whereas in my opinion, servers are mostly very high-level hardware. And I think that's not the problem with low-level hardware. What you didn't mention, and this is not a question, there's also an embedded Swift part at swift.org, and that is for really low-level hardware, where we only have 2K of memory. And Swift is also moving in that direction, also by instigation of Apple, that wants to use Swift on their embedded devices like your AirPods, which are currently still programmed in C++. So this was not a question, sorry.
Okay, the magnet works, Marco. Anybody have another question, maybe? Because otherwise I will do my outro and tell you what's next. So, okay. We have a break now till 10:45. I think you say 10:45, so that's about 35 minutes. And we have some drinks and some small snacks. I think you call them canapé. On the other side of the curtain. We can use this room where we are at right now and the room behind the curtain. If you take your glasses into this area, once you're done with it, please bring it out to the other side of the curtain again, because otherwise we'll be tripping over the cutlery and we'll be breaking things all of a sudden, and that would be a bit sad. So thank you for your attention for the first presentation. Thank you, Ben. It was great seeing you on stage again. And yeah, let's have a drink and interact with each other.